Welcome to the fifth video of Chapter 11, which is Areas of Circles and Sectors. This is a continuation of the last video, 11.4. Last video we talked about circumference, so like perimeter, the distance around a circle. Now we're going to talk about area, all that stuff inside a circle. We're going to do two things, calculate the area of circles, and then we're also going to do sectors. First thing we should probably talk about is how to calculate the area of a circle. So the area of a circle, you should probably already know this, is pi r squared. R stands for the radius. That shouldn't be anything new. We have two examples. So example number 1 says find the area of a circle with a radius of 2.5 centimeters. So we're going to start by writing our area formula. Area is pi r squared. In this case, we are told the radius is 2.5. So I'm going to have r be 2.5. Now, order of operations, I want to square first. So I'm going to do that 2.5 squared, which is 6.25. So my area then is 6.25 pi centimeters squared. Remember, area is always centimeters squared. Now this is the exact area. Exact because I kept pi. I would really prefer that you keep your area exact, but I know that some of you like decimals, so you can convert this to a decimal if you would like. Remember that you have the pi button on your calculator. So as an approximate area, this area could also be expressed as 19.635 centimeters squared. Again, that's the approximate. Exact is always when you leave pi in your answer. So that's it. Not too bad. The most difficult part to remember is to square the radius before multiplying by pi. Besides being able to calculate the area of a circle, you need to be able to work backwards. So if I give you the area, you need to be able to calculate a radius. Example number 2 says find the diameter of a circle with an area of 113.1 millimeters squared. So I'm going to do this one with you. Start out with your blank area formula. So area equals pi r squared. I'm told the area is 113.1, so I have 113.1 equals pi r squared. Okay, I'm asked to find the diameter. So I just need to keep that in the back of my mind. The equation I have now will help me find the radius, which I can use to find the diameter. Okay, so I have 113.1 equals pi r squared. I need to solve for r, so I'm going to need to get rid of that pi, and I'm going to need to get rid of the squared. By order of operations, I want to start with dividing by pi. In your calculator, when I divide 113.1 by pi, I get 36.001 is equal to the radius squared. Now to get rid of that squared, I'm going to take the square root. Because I divided by pi, this is just an approximate answer, which is why I'm doing the squiggly equal sign, but my radius is about 6 millimeters. Millimeters because of the problem. Now, if my radius is 6 millimeters, my diameter is going to be double that. So my diameter is about 12 millimeters. So that's nothing too new. This should be something that you've done before, probably in Algebra 1, probably in middle school. The part that's more difficult is what we're doing next, the area of a sector. Now, we've not used the term sector before, but we do have a picture here. A sector is this part right here. It's like a piece cut out of the pie of the circle. It's a little portion cut out. So we're going to be finding the area of that sector. It's very similar to finding arc length, except we're going to use area this time instead of circumference. So in order to find the area of a sector, you do the measure of the sector over 360, because the entire circle is 360. That's equal to the area of the sector over pi r squared. Remember, pi r squared is just the whole circle. So anytime you're asked to find the area of a sector, you're going to be setting up a proportion and solving it using the cross products property. So this should look almost identical to what we did last section. What changes is the pi r squared and the area. Before it was arc length and 2 pi r. So let's look at example number 3. It says calculate the area of the sectors. So we're going to have to calculate the red sector area, and we're also going to have to do the blue sector. On yours, I think they both show up as gray. So let's start with the red. Now, my sector is 70 degrees, so it's going to be 70 out of 360 equals the area of the sector. I don't know that. That's what I'm solving for. So x over pi r squared. In this case, our radius is 8. So this becomes 70 over 360 equals x over 8 squared is going to be 64 pi. Now I'm ready to do my cross products property. I'm going to continue all the way to the left. 360 multiplied by x is just 360x. 70 multiplied by 64 is going to be 4,480 pi. I'm going to divide by 360. This gives x equals 4,480 divided by 360 simplifies to 1/12 over 9 pi. So that's the area of the sector. Now that doesn't mean a whole lot to us because we can't do that in our head. So I'm also going to give you an approximate answer. That's approximately 39.10, in this case, units squared, since we don't know what the units are. So that's the area of the red sector, the red pizza cut, the red pie cut, the red pizza slice, I guess. Now we also have to find the blue sector. It's going to be very similar. This time we are not given this measure. Well, remember that the entire circle is 360. So if I take 360 and I subtract 70, I know that this blue measure is going to be 290. So I have 290 over 360 equals x over pi times 8 squared. So it's the same setup. All that I changed was the measure. Instead of measuring 70 degrees, the sector measures 290. So this becomes 290 over 360 equals x over 64 pi. Now I'm ready to do my cross products. I get 360 pi equals 18,560 pi. Oh, I'm sorry, this should be 360x. Sorry, my mistake. The 360 gets multiplied by the x, not the pi. So 360x equals 18,560 pi. I divide by 360. So x is equal to 464 divided by 9 pi. Remember, do 18,560 divided by 360 in your calculator. You hit math frac, turns it into a fraction. Again, this doesn't mean a whole lot to us because we can't do this in our head. So to give us a little bit better idea of how much this is, I'm going to give you the decimal approximation, which is 161.97 units squared. So this should be very similar to what we did before. All that we changed was the pi r squared. We used to use 2 pi r, now we're using pi r squared because it's area. So we set up 2 proportions, 1 proportion for the red sector, 1 proportion for the blue sector. I would prefer that you keep your answers exact in terms of pi, but occasionally I will ask for a decimal answer. Now that we have the basics, let's move on to some other examples. Okay, so example 4, it says calculate the area of circle V. This one I would like you to try. This is similar to what we did yesterday, in yesterday's video. You were given a setup like this and then asked to find the circumference of the circle. And I told you there's a long way to do it and there's a short way to do it. And I showed you the short way. So set this up and see how you do. Pause the video. Come back after a few minutes after you've had a chance to try the problem. Good luck. Okay, let's see how we did. So the measure of our sector is 40 degrees. The entire circle is 360. Now that 35 is the area of the sector, not the circle. So the 35 is going to go in our numerator. And then I have pi r squared. Now I need to think, what am I solving for? I'm solving for area, which is pi r squared. Just keep that in the back of your mind. So let's do our cross products. 360 multiplied by 35 gives 12,600. That's equal to 40 times pi r squared. Next, I'm going to divide by 40. And I get 315 equals pi r squared. Now from here, I could solve for the radius. But if I'm tricky, I know that this is my answer. I want to calculate area. Remember that area is pi r squared. That's what I have right here, pi r squared. So my area is just 315 meters squared. What you could do is solve for the radius and then substitute back into the formula. It's going to be a little more work. You should still get the same answer. But you can actually just stop right here and say my area is 315. So hopefully you saw that little trick. If not, hopefully you now see what I did. Okay, let's look at our next and last example. So anytime I think about a sector, I think about a basketball court. So as you can see in our basketball court in this picture, we have this little sector up here. It's actually called a semicircle. It's half of a circle. And then we also have this rectangle here. So what we're going to be doing is we're going to be finding the area inside of this red portion and this blue portion. I'm not a basketball expert, so I'm going to call it the lane. I don't know if that's right or not. So on our figure, I want to find this area, the area inside this lane. So I already told you, you're going to have to find the area of the rectangle, and then you're also going to have to find the area of that semicircle. I'm going to help you with the semicircle, and I'm going to let you do the rectangle. Or I'm going to help you with the rectangle, I'm going to let you do the semicircle. On the next page, I have this picture, but a little bit bigger. Okay, so again, we are finding this right here. So we already said we're going to have to do the rectangle, add the semicircle. Okay, so our rectangle is going to be base times height. This is one dimension of the rectangle. Here's the other one. Okay. So I'm going to notice that the base, this length, is 18 feet 10 inches. The height, right here, is 12 feet. Okay, so the first issue I notice is that I have both feet and inches, which is going to be a problem. I need to pick. Do I want to use feet or do I want to use inches? I think it's easier, personally, to convert feet to inches, so I'm going to convert all the feet measurements to inches. So 18 feet is going to be 18 times 12. That will give me the amount of inches. And then I have those extra 10 inches. So when I do that, I get 18 feet and 10 inches is the same as 226 inches. Now for my height, 12 feet multiplied by 12 inches in a foot will give me 144 inches. Okay, then I need to multiply, remember, to find the area. When I multiply 226 by 144, I get 32,544 inches squared. Okay, but remember, that's just the rectangle portion. It's up to you now to calculate this portion right here. So I would like you to find the area of that portion, make sure to use inches, and then find the total lane area. When you come to class tomorrow, I'll be checking to make sure that you have a final answer. And we'll be going over any questions that you have. Please make sure if you have any questions that you write them down and bring them to class tomorrow. See you tomorrow.